Okay, so we went through systems of linear equations in two variables. Oops, sorry. We talked about how we had three types of solutions: independent system, inconsistent system, and dependent system. How independent means there's one where they cross. Inconsistent means they never cross, there's no answer. Dependent means that one is just, we have two equations where one is hiding out like the other one. So it's dependent, meaning you just have a linear equation. Y depends on X. Then we discussed if a point is a solution, basically, is this point where they cross paths? So if your xy satisfy both equations, then yes. If not, then no. So how do we solve for these suckers? This is the substitution method. So we isolate one of the variables in one equation, substitute into the other, solve the remaining variable, and then plug back in to find the other. So what I like to do when I'm looking at two equations is I just look at them. Let's say, for sake of argument, the top one is one, the bottom one is two. I'm looking at them and I say, okay, well, one is pretty easy to just isolate and solve for X. So it's just a very, I guess I'll say simple. X equals 43 minus 8y. So now, if this is a system where they cross paths, if X equals 43 minus 8y for one, then 43 minus 8y has to equal X for the other. Otherwise, it's not a system and it doesn't work out. So we're just going with that assumption, and that's how we kind of start this whole deal with. So now with example 2, you move forward with substituting, hence the name, in the value of X, in this case, 43 minus 8y, into X minus 2y equals -1. So now we have what we could have gone over like day 3 of class, a linear equation in one variable, which we love because now it's not too challenging to solve for y. So I want you to get used to or back in the habit of going backwards. Ask yourself, what are we solving for? Y. How many y terms are there? Two. We only want one. Because how do we know when we're done? When we have y equals, y by itself, y equals a number, all that fun stuff. So having two, not cool. Having one in parentheses prison, less cool. But do we know how to get it out of parentheses prison? How to jailbreak? We sure do, by distributing that 3. So then we have, let's see, 3 times 43, 3 times 3 is 9, 3 times 4 is 12. 3 minus 8 or times -8 is 24y. Minus 2y equals -1. Combining like terms, 129 minus 26y equals -1. Solving for y. So I am just going to add the 26y and then add this 1 so that we end up with 130 equals 26y. And then remember, it's 26y, but also AKA 26 times y. Let me scooch this over. So we could also say what undoes times division. So that is 5. But are we done? Just because we found y, we're not done. We have to find both, right? Because the answer is an ordered pair. Remember that the answer is the ordered pair X comma Y. And we use the braces to say, like a signpost to say, hey, and here's the answer. Yoo-hoo, over here. But okay, I digress. So now that we have Y, we're going to come back over here to solve for X. So we know that X is 43 minus 8. Y is 5. So this is 43 minus 40. So X is equal to 3. Now we're done. So the answer is 3, comma 5. Is it okay if I do 5 comma 3? Is that the same thing? Is that okay? No, not okay, right? Ordered pair. X first, then Y. X first, then Y. So don't go too fast, right? Make sure that you're paying attention. The Y is 5, X is 3. Because if you write 5, 3, you're wrong because X is 3, not 5. Okay, so here we're actually going to solve this one by, let me see. Uh, let's see. Yeah, we're going to solve this one using graphing. So substitution, pretty much the same thing. Well, I'll set it up. So again, if I was going to substitute this, say this equation 1, equation 2, I would again just take the second equation, say x equals 2y minus 3. So then this gets plugged in for x. So then 1 is 5 times 2y minus 3 minus 4y equals 9. Distribute the 5 because we have 2 y's. 1 y is in parenthesis prison. We're not cool with that. We need a jailbreak so that everything can move freely about the cabin. Right? Seatbelt sign turned off. Combine like terms. So 10y minus 4y is 6y. I'm just combining these two. And then add the 15. Add the 15. Let's see. So that is what, 14y. So y is equal to 14 sixths, which divided by 2 is 7 thirds. And then if y equals 7 thirds, we just pop that in there. So x equals 2 times 7 thirds minus 3. So x is equal to, let's see, 2 times 7 thirds is 14 thirds. And then it was minus, what was it, 3? Yeah. And then I'm just going to say math, enter, which is 5 thirds. So here we have 5 thirds, comma, 7 thirds. Okay, substitution method. But I want to show you graphically. Because if you have a fancy graphing calculator, you might as well know how to use it. So if I take equation 1, 5x minus 4y equals 9, just solve for y. So subtract the 5x. So negative 4y equals negative 5x plus 9. And then divide by the negative 4. Don't get fancy, just, the less you do, the better, so that you don't accidentally make an algebraic mistake and then everything's wrong, blah, blah, blah. So do less. For example, 2, or equation 2 rather, I'm just subtracting the x over, and then I'm going to divide by the negative 2. So I'm going to call this y sub 2. So over here is y sub 1. So negative x minus 3 all over negative 2. And then I'm just going to put these into the calculator. I already have them in here. Good. Go me. So here, 9 minus 5x is the same thing as, negative 5x plus 9 all over 4. Over here, I have 3 plus x all over 2 because, again, that's the same thing as what we have. I just moved that negative up. So essentially, I just flipped all the signs. Same thing. So now when we graph, the answer, remember, is where they intersect. So you want to go second calc or second trace. And notice, what does 5 say? 5 says intersect. So you move your cursor. I'm just pressing the right arrow to where you're close or even on. Enter. So it says, okay, my intersection is there. Did I press enter too many times? That says 5, comma 4. Maybe I did my This says 5,4. Let's see. That kind of tells me I probably did something up here in the green wrong, which is quite possible. 10y minus 4y is 6y. 5 times negative 3 is negative 15. 9 plus 15 is 14. 14 divided by 6 divided by 2, reduced by 2. 7/3. See, y'all probably saw it and you screamed at me, as you should. Let's see. Adding 2y minus 3 equals x. So that's 10. I'm sorry, I don't need to like scream. You know, I don't need to watch me or actually just stare at the screen while I figure out my mistake. I'm sure you saw it and you're just staring at it in the face. It's going to drive me nuts. See, 9 minus, here, let's just see. We can go to Desmos. Desmos graphing, Desmos calculator. See, now we go here, 5x minus 4y equaling 9. 5x minus 4y equals 9. Okay. And then we'll add the other one. X minus 2y equals negative 3. X minus 2y equals, oh, is it negative 3? Yeah, that's 5/4. I did something wrong in my 5/4. Yeah. So this is it. Come on, highlighter. This is the answer. Well, now I'm super bummed. I don't want to waste your time by just staring at it. I hope that, did I write something down wrong? Adding the 2. Okay, I'm going to move on because you don't want to have to stare at me. So this is the same. This is correct process. I made a mistake somewhere. Mistake somewhere. Somewhere, but won't waste time looking. Sorry, y'all. It's in there. I'm sure. I hope you saw it and you're like, oh, you silly woman. You should, as you should. This is why videos are not my fave, but it's a means to an end. Okay. But my point there, anyways, was graphing. So you saw how I did it in the calculator and for homework and whatnot. You saw how you can also use Desmos for help as well. Desmos is pretty cool. So addition elimination method. This method is really quite cool. It is a method we are going to use when we hit matrices. So tried and true method. One thing I want y'all to notice is that you have like this X column, the Y column, and a number column. And really, if you're paying attention, all of the systems have been set up that way so far, right? You have an X, a Y, and a number column. So they're all set up in this nice way, basically to help us with this addition elimination method. So 1 says write both equations in the standard form, ax plus by equaling c, because you need everything lined up for the elimination to take part. 2, if necessary, multiply one or both equations by constants to create opposite coefficients for one of the variables. Add the equations and solve for the remaining variable, and then plug back in to find the other variable. So kind of similar to the end of substitution, but a little bit different as well. So when you're adding or eliminating, you look at the equations and you say, okay, equations, my goal is to add down in one variable, a variable, zero out. That's Okay, that's the goal. You want to do it so where they add down, a variable zeroes out. You look and you just kind of say, okay, I want the path of least resistance. What can that be? It's different for everyone. And sometimes you just got to take a stab and just do something to get the ball rolling. If like you don't see anything that's clear cut, like easier, just start. Okay, so what we're going to do is I say, okay, let's do X. It's totally arbitrary. If you want to do Y, do Y. Doesn't matter. But I'm going to do the X's because I see that, oh, okay, well, 2 times 3 is 6. So I am going to add equation 1 to a -3 times equation 2. And watch what happens. So I'm just rewriting equation 1. So 6x minus 5y equals -34. And then I'm running a -3 through all of equation 2. So -3 times 2 is -6x minus 18y equals -12. Because again, we ran a -3 all through equation 2. So when we add down, specifically what happens? Yeah, those sixes zero out like we wanted to. So when we add back down, we end up with negative what? 13y equals negative 2 plus 4 is 6 plus 3 plus 1 is 46. So divided by 13. My brain's not working. Oops, yeah. 46 divided by 13. Math, enter. 46 13ths. Okay. And positive because negative over a negative. 46 13ths. Okay, that still feels weird, but we're going to go with it. Okay, so that's why. So now that we have y, you just go back to either equation 1 or 2 and you plug that back in. Oops, sorry. I just want to make sure that I'm not messing up again. So let's just dot our I's and cross our T's. 23. Okay, yeah. Again, y'all are probably screaming at the video and be like, that's 23, you dummy. Yeah, I just knew this felt so weird. Okay, 46 divided by 23 is 2. Yes. Ooh, that feels better in my bones. Okay, much easier. So now we know that y equals 2. You pop it into any version. Let's just do equation 2 for no particular reason. So equation 2, we're popping in 2x plus 6 times 2, because we found that's what y equals 4. So 2x plus 12 equals 4. So 2x equals what? Subtract 12 over, that's -8. Divide by 2, x equals -4. And because this is 2x equals -8, but remember a different way to phrase it is 2 times x. What undoes times? Division. And then yay. So the answer is it 2 comma -4? No, right? Remember, we got to be specific order. It's an ordered pair, x comma y. So it's -4 comma 2. Yay, go us. Okay, I want you to pause the video and I want you to do number 6. Pause the video and do number 6. And then play when you're ready. Okie dokie. So first off, when I look at number 6, I notice that we are all in wonky order. We do not have our streamlined XYZ column. So the first thing we want to do is rearrange it so that I have 2x. We're going to subtract the 7y to the left equals -17. Then I'm going to add for equation 2. I'm going to add 3x to the left. 5y stays there, so plus 5y equals +17. Then, for sake of clarity, equation 1 and 2. Now I'm looking, and we say again, okay, I want a variable to disappear, I'm just going to go with the lower numbers with x, 2 and 3 smaller than 7 and 5. So that things just end up a little smaller. But really, if you want to get the common multiple for 5 and 7 of what is that, 35, go crazy. I'm just going to do a 6. But if I want a 6, right, a common multiple of 2 and 3 is 6. That means I'm going to run a -3 through equation 1 and a +2 through equation 2. Because again, we're looking at this one here. I'm running a -3 through equation 1. So -3 times 2 is -6x, then plus 21y equals 17 times -3, 51. Running a 2 through equation 2. So 2 times 3 is 6. So 6x. 2 times 5 is 10y. 2 times 17 is 34. Let's just check because y'all have seen how my brain is working today and it's not well. Okay, there we go. Perfect. Aha! As we want, the x's zero out. Going to continue to add down so that we get what? 31y equals 5 plus 4. Excuse me, 1 plus 4 is 5. There we go. 5 plus 3 is 8. So 31y, same thing as 31 times y. So divide 31 over 85 over 30. But are we done? We wish. Now we go back and plug it in. It's either equation 1 or 2, totally does not matter. Let's just do equation 1 because I don't think we've done that one. So this is 2x minus 7 times 85 over 31 equals -17. So 2x equals, I'm going to add this over, -17 plus 7 over 85 over 31. Grab my calculator, slide it over. Okay, -17 minus, plus parenthesis 7 times, let's get fancy and grab our fraction, 85 over 31. Math, enter, 68/31. So 2x equals 68 over 31. Divide by 2. Same thing as multiplying by a half. See, 68 divided by 2 is 34. So 34/31. Divide by 2. Math, enter. 34 over 31. Again, x is first, so it's 34 over 31, comma 85 over 31. There we go. Yay! If you have questions, write them down, email me, see me in office hours, all that fun stuff. Okay, pause the video and I want you to try 7 and 8 on your own. Pause the video and try 7 and 8 on your own. Okay, I know you paused and you tried it and you're back. So again, clarity 1 and 2. I'm looking to make sure I have my X, Y, and number column. Looks good to me. So here I see, okay, I have 3x minus 2y equaling 5, and then 9, 6, and 15. With equation 1, the signs change. With 2, we're just going to see what let's just multiply equation 1 through by a 3 so that the 6's or the y's will cancel out. because negative 6y plus positive 6y will zero out, but watch what happens. You probably can see it already. All right, so I'm running a 3 through equation 1. So this is 9x minus 6y equals 5. I'm going to add it to just plain old equation 2, which is 9x plus 6y equals negative 15. Oops. And when we add down, what happens? Yeah, everything zeroes out. But that's okay, because does 0 equal 0? Yeah, that's true. So what this tells me is that this is a dependent system. This is a dependent system. Because if you look closer at equation 2, if I run a 1/3 through equation 2, negative 9, or let's do a negative 1/3 through equation 2. So 9 divided by negative 3 is 3x. 6 divided by negative 3 is a negative 2x. And then negative 15 divided by negative 3 is a positive 5x. So 2 is the version of equation 1 just parading through as equation 2. 2 is a version of 1, yeah, or 1 is a version of 2. If I take equation 1 and run a negative 3 through it, we get equation 2. So it's a dependent system, right? It's the same equation, just in a costume of in a costume. We'll just put it that way, leave it at that. So it's the same equation written twice. One's in a costume, so to speak. So the way you write it is, I would take its simplest form, which is equation 1, solve it for y so that it's in terms of x. So I'm going to subtract the 3x over. So negative 2y equals negative 3x plus 5. Divide by negative 2. You don't have to like simplify or anything like that. The less you do, the better. Okay, so then y is in terms of x. So my answer is x comma negative 3x plus 5 over negative 2. So again, x is what we call the free variable, and then y depends on x. If you want to distribute that negative through into the numerator, whoop, that's an arrow, forgive me. You also have x comma 3x minus 5 all over positive 2. Same thing. I do expect you to recognize that those are the same thing, by the way. Okay, so this is a dependent system because 1 and 2, same equation, just one is in a costume. Okay, so we've looked at several equations that are independent. We just saw a dependent. I bet you can guess what the last kind is. The last one, yeah, it's inconsistent, but let's talk about how we know. Okay, so again, sake of argument, 1 and 2. Equations 1, equation 2. What variable do you want to eliminate? I'm going to go with x just because 4 and 6 are smaller numbers than 6 and 9, but there's really no reason. 4 and 6 both go into 12. So let's do what? Negative 3 times equation 1. Hang on, sorry, eraser. Negative 3 times equation 1 is negative 12x minus 18y equals negative 36. And I'm going to run a positive 2 through equation 2 so that when we add down, I get negative 12x plus 12x, and they should zero out. So 2 times 6x is 12x. 9 times 2 is positive 18y. 12 times 2 is 24. But maybe you see it, because what happens with the x's? They zero out. What happens with the y's? They zero out. But here, We're left with negative 12. Last I checked, 0 does not equal negative 12. So liar, liar, pants on fire. So inconsistent. This is inconsistent. Inconsistent. If you think of like inconsistent stories, like some things just don't add up, they're not matching up, like there's inconsistencies in a timeline, right? Something is amiss. So inconsistent, right? 0 doesn't equal negative 12. No solution. No solution. Empty set. The 0 with a line through it. It's like an O with a line through it. The null set, empty set. Or D and E, right? Does not exist, but that's it, right? There's no solution. No solution. Okay. So those are the examples and the various ways to solve them. Example 4 is still going to drive me nuts. I made a mistake, but again, I won't stare. Hopefully you find it, but I won't waste your time with me staring to find it. Okay. I think that, yeah. Please let me know if you have any questions at all.